This is a GCE O-level Pure Physics revision series. In this video, we are going to discuss important physics definitions that you must know before you take your exam. There are two chapters to talk about, which are Chapter 16, Static Electricity, Chapter 17, Current Electricity. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us. Also, check out the description area to sign up to our signature course, GCE O-level Pure Physics full course, at unbelievable price. It's one-time payment. You can study anytime you like, anywhere at your convenience. You can also easily monitor and track your study with Udemy's system. There is no recurring monthly tuition fees. No expensive intensive revision workshops. You don't have to rush to any tuition centers. You don't have to worry on missing any lessons. Sign up our signature online course at description area now. Without further ado, let's get started now. Chapter 16, Static Electricity. Electric charge. All matter is made up of particles called atoms. The atom has electrons orbiting the nucleus, which consists of protons and neutrons. Protons have positive charges. Electrons have negative charges. Neutrons have no charge. The SI unit of electric charge is Coulomb, c. The electric force is the attraction between unlike or opposite charges, or repulsion between like or similar charges. In electrical conductors, there are electric charges, which is electrons, that can move freely within the object. Electrical insulators are material in which the electrical charges cannot move freely. Electrostatic charging and discharging. Electrical charging happens due to the transfer of electrons from one object to another. When an object has an equal amounts of protons and electrons, it is known as an electrically neutral object. When an object is lack of electrons, it has a net positive charge. When an object has excessive electrons, it has a net negative charge. Solid insulators can be charged by rubbing or friction. Solid conductors can be charged by induction. Discharging is the process of neutralizing a charged object by removing excess charges. Electric field. An electric field is a region in which an electric charge experiences an electric force. The direction of the electric field line represents the direction of the force experienced by a small positive test charge within the electric field. Chapter 17, Current Electricity. Electric current. An electric current, I, is the rate of flow of electric charge through a cross-section of a conductor. Hence, its formula is I equals Q over T. The SI unit of electric current is the ampere, A. The direction of conventional current is from the positive terminal of a cell or battery to the negative terminal. It is opposite to that of electron flow. Electromotive force and potential difference. Electromotive force, or EMF, symbol epsilon, of an electrical energy source is the work done W by the electrical energy source in moving a unit charge around a complete circuit. Hence its formula is epsilon equals W over Q. Potential difference, or PD, symbol V between 2 points is the work done W in moving a unit charge between these 2 points. Hence its formula is V equals W over Q. The SI unit of both EMF and PD is the volt, V. Resistance. Resistance, R, of an electrical component is ratio of the potential difference, V, across it to the electric current, I, going through it. Hence its formula is R equals V over I. Or R equals rho, L, over A. The SI unit of resistance is the ohm, symbol omega. Resistivity, rho, is a measure of how much a material opposes the flow of electric current. Ohm's law. Ohm's law states that the current, I, passing through a conductor is directly proportional to the potential difference, V, across it when the physical conditions are unchanged. Conductors that obey Ohm's law are said to be ohmic. Their resistance remains constant under constant physical conditions and their IV graphs are linear. Non-ohmic conductors do not obey Ohm's law. Their resistance varies. That's all for this video. Thanks for watching. Do you have any thoughts, opinion or experience want to share? Write it down in the comment area. We'd love to hear from you. Also, do you like this video? Don't forget to like and share it to your friends. Until then, see you in the next video. Have a great day ahead.